Hello friends, myself R.D. Mahajan presenting my video on Gauss Seidel method. Let us solve following questions by Gauss Seidel method. 10x plus 2y plus z equals to 9, first equation. Second, 2x plus 20y minus 2z is equals to minus 44. And the third one, minus 2x plus 3y plus 10z is equals to 22. As we required to solve it by Gauss Seidel method, first of all, we check the condition for convergence, as I have discussed in my earlier video. Here the first diagonal element is 10. Absolute value of 10 must be greater than sum of the remaining values, absolute value of the remaining terms. Therefore, 2 plus 1 we get 3. Therefore, 10 is greater than 3. Condition is satisfied here. Second diagonal element is 20. Absolute value of that 20 is 20. That is greater than sum of this absolute value. 2 plus 2 we get 4. Therefore, 20 is greater than 4. Third equation, absolute value of 10 is greater than remaining absolute values, sum of the absolute values, that is 2 plus 3, 5. Therefore, here as the condition of convergence is satisfied, condition of convergence is satisfied, solving the equation for the highest coefficient. First equation we have to solve for x. Therefore, we get x is equal to 1 by 10 times, transferring all other terms to the right hand side, it is 9 minus 2y minus z. We call this as first equation. Second equation we have to solve for this y. Therefore, we get y is equal to 1 by 20 times minus 44 minus 2x and plus 2z. We call this as equation 2. Then solving the third equation for z, highest coefficient. Therefore, 1 by 10 times 22 plus 2x and minus 3y. We call this as equation 3. A first step. And then we have to apply the Gauss Seidel method. For clear understanding, watch the video up to end. Therefore, I will discuss this procedure. Step number 1, we use equation number 1 to find the first approximation for x. Therefore, step 1, where we find first approximation for x as on the right hand side we have the two variables y and z, substituted initially both as 0, and therefore we get here 1 by 10 times 9 minus 0 minus 0, and fix your calci for 3 significant digits. Therefore we get 9 by 10, and 9 by 10 is 0.900, and we put that value here in the table simultaneously. The first value of x is 0.900. Use that value in equation 2 along with the value of z as 0. Therefore, from second equation we get the first approximation for y1 as 1 by 20 times minus 44 minus 2 times x. X is 0.900 and plus 2 times z. Z is 0. Perform this by calci. It is minus 44 minus 2 into 0.9 and divided by 20. It is coming as minus 2.290. First approximation for the y, and therefore substituting that value here in the table, we get minus 2.290. Then using these two values x and y in z, means in equation number 3, we get the first value for z, our first approximation for z as 1 by 10 times 22 plus 2 into x. The latest value of x, or the new value of x, is 0.9, and minus 3y. The value of y is minus 2.290, and if we perform by calci, it is 22 plus 2 into 0.9 minus plus 3 into 2.29, 3.067. Substituting that value here in the first table, the value of z is 3.067. Then we have to repeat the same steps once again to find the second approximation for the values of x, y, z by substituting the latest values for step 2, iteration number 2. Once again using that equation 1, 2, 3 to get new approximation. Therefore x2 is equals to, this time we have to use y as minus 2.290 and z as 3.067. Therefore we get x2 as 1 by 10 times 9 minus 2 times y is minus 2.290, and minus z is 3.067. And simplifying it, performing that calculation by calci, we get that 1.051. Substituting here, we get 1.051. Using it here in second equation and the value of z as 3.067, we get a new approximation for y as y2 1 by 20 times minus 44 minus 2 into x is 1.051, and plus 2 times z is latest value of z is 3.067. Simplifying it, minus 44 minus 2 into 1.051 plus 2 times 3.067 and divided by 20 minus 1.998. We put here in the table minus 1.998. Then using equation third, by substituting new values of x and y, new value of x is 1.051 and new value for y is minus 1.998, we get new value of for z, or second approximation for z, as 1 by 10 times 22 plus 2 into x. The value of x is 1.051 and minus 3y. Y is new value for y is minus 1.998. Every time remember that we have to use the latest values for the variable, and it is easy to substitute if you make a table like this. And therefore simplifying it by calci, always try to check the answer by performing the calculation yourself. We get the value 3.010. Substituting here, we get 3.010. If the successive values are nearly equal, we can stop the iterative procedure. If the values are not equal, like here, values are not equal, we have to go to the next step or next iteration. Therefore, performing step 3, once again applying the same 3 equations to get the new approximation for the values. Therefore, we get x3 is equals to 1 by 10 9 minus 2 times y. The latest value of y is minus 1.998 and minus z. The value of z is 3.010 0.993 for step number 3 or iteration number 3. Therefore, substituting this value here in the table for x, we get 0.993. Then using equation 2, we find y2 as, here on right hand side we have x and z. Therefore, the latest value of x we substitute 0.993 and the latest value for z is 3.010, and therefore performing that step we get 1 by 20 times minus 44 minus 2 into x. X is 0.993 and plus 2 times z. The value of z is 3.010 minus 1.998. Therefore, we put here minus 1.99. Using these two latest values of x and y in equation 3 to get a new approximation for z. Therefore, from third equation, z3 is equals to 1 by 10 times 22 plus 2 into x. The value of x is 0.993 and minus 3y. The value of y is minus 1.998. Simplified value 0.998. Substituting here in the table, we get 2.998. Once again, if you observe, these two values are not equal. These values are equal and the value of z is not equal. Exactly equal or nearly same. Then we have to stop the iterative procedure. As the values of x are not equal, we go to the step number 4. Once again applying the same 3 equations by substituting the latest values, and therefore we get x4 new value as 1 by 10 times 9 minus 2y. The latest value of y is minus 1.998 and minus z 2.998. Simplifying it, we get 1.000. We put that value here, 1.000. Then using it here in equation 2 to get a new approximation for y4 as 1 by 20 times minus 44 minus 2 into x. X is 1.000 and plus 2z. the latest value of z is 2.998. Therefore 2 times 2.998. Performing the calculation, minus 2.000. Using these two values here in equation 3 to get a new value for z, z4 as 1 by 10 times 22 plus 2 into x. The latest value of x is 1.000 and minus 3 into y. The value of y is minus 2.000. We get that value 3.000. Therefore, we put that value here. Step number 4, iteration number 4 is completed. Again, these two successive values are not equal or nearly equal. We have to go for one more step, iteration number 5. Step number 5, by using this latest values or the new values. Therefore, from equation 1 we get x5 is equals to 1 by 10 times 9 minus 2y. The value of y is minus 2 and minus z. The value of z is 3. And simplifying it, we get that value as 1.000, fifth iteration. Then using that in equation 2, we get a new approximation for y, y5 as 1 by 20 times minus 44 minus 2 into x. Value of x is 1.000 and plus 2z. The value of z is 3.000. Simplifying it by calci, we get minus 44 minus 2 plus 2 times 3 and divided by 20. It is coming as minus 2.000. Then using these two values in equation 3, we get z5 as 1 by 10 times 22 plus 2 into x. The value of x is 1. Y, 3 times y. The value of y is minus 2.000. And performing the calculation or simplifying it, the simplified value is 3.000. We get that value as 3.000. And if you observe the two successive values, that is for step number 4 and step number 5, x is 1, same values. Successive values of y are minus 2.000 and the successive values for z as 3.000. And as two successive values are nearly equal or equal, we can stop that iterative procedure. And therefore, the final solution by Gauss Seidel method is x is equal to 1, y equals to minus 2 and z equals to 3. As two successive values of x, y and z are same or equal, we stop the iterative procedure. And therefore, the solution is x is equal to 1.000, value of y is minus 2.000 and the value of z is 3.000. And then we can cross check whether the required or obtained solution is correct or not by substituting these values in the original equation. We can call it as cross check. Therefore, I will perform for the first. Therefore, cross check 10 into x, we get 10 into 1, plus 2 into y is minus 2.000, and plus z is 3, and that is equals to 9 on right hand side. Therefore, 10 into 1 we get 10, minus 4 and plus 3 equals to 9. We get 6 plus 3 we get 9 equals to 9. First equation is satisfied. Similarly, cross check for the remaining two yourself. If these two equations are also satisfied, then we can say that the obtained solution is a correct one. Therefore, this is the way in which we can find the solution of given simultaneous equation by applying Gauss Seidel method. One more I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to get a notification for my new videos. Thank you.